Welcome students to our new YouTube channel Pharma Extech, the division of excellence. So in the last video lecture we see the suspension. So in the next we see the emulsion. So let's start to this chapter, emulsions. So the emulsions, there are two types of emulsions such as oil in water and water in oil type of emulsion. So we use these emulsions in our daily life. So the formulations which are based on the emulsions, the examples of these liquid formulation which is based on the emulsion is gelusil. The gelusil is used, we use the gelusil as an antacid, that means for the acidity. The gelusil is an antacid agent and which is used in stomach and which relieve the your acidity in the stomach. So this gelusil is the emulsion and this gelusil is form the two layers and the color of this gelusil is pink. So this creamy color of the gelusil is due to the coloring agent. So and also the other compound, other drugs or other liquid formulations, they are emulsions are used in the antacid. So other very long antacids are the emulsions. So the other products of emulsions are, that means other products of the antacids are also based on these emulsions. So they are in very large numbers. So we see in the emulsion, so we see in the emulsion the some basic and important points in the emulsion, and not the whole theory is not important for your GPAT exam, and this theory is important for your only your theory exam. So in GPAT some important points are most important. So in emulsions, the droplets ranging in diameter of 0.1 to 100 micrometer. So the droplet size of the emulsion ranging in diameter of 0.1 to 100 micrometer, and also they are thermodynamically unstable and these stabilized by the presence of emulsifying agents. They are known as emulsions or emulsifiers. So these emulsions are the formulations, they are thermodynamically unstable and they stabilized by the presence of the emulsifying agents. So these emulsions is no more officially in Indian pharmacopoeia. So and also this emulsion protects the drug which are susceptible to hydro and oxidation, and this emulsion it is also provide the prolonged action of medication, and in the form of oil in water emulsion, the ephedrine has more prolonged effect when applied to nasal mucosa than when used in an oily solution. Then next we see the test for emulsions. So the test for emulsions, they are dilution test is used for the emulsion. In that, first we add the water to a water in oil emulsion, and oil in water emulsion would crack the emulsion and lead to separation of the phases. So and also the conductivity test, there is O by W, that means oil in water is the current flow and water in oil is the current but not flow, and oil in water is the current not flow when purified water instead to potable water is taken. The next test for emulsion is dye test, not dry test, is the dye test. The dye test, in that the amaranth oil in water emulsion and Sudan 3, that means Sudan red, is W by O emulsion, that means oil in water emulsion. The next is fluorescent test. So this fluorescent test is water in oil is the entire field of fluorescence. So this water in oil emulsion is the entire field of fluorescence, and oil in water is the fluorescence is spotty. So in the oil in water emulsion, the fluorescence is found the spotty. So next test is filter paper test. So the filter paper test, in that the oil in water emulsion will spread out rapidly when drop on to the filter paper. In contrast, oil in contrast to water in oil, that means W by O will migrate slowly. Then next is cobalt chloride test. In the cobalt chloride test is the filter paper soaked in CoCl2, and that means in soak in CoCl2 solution and allow to dry, and this turn blue to the pink on evaporation to oil in water emulsions. And next we see the some examples of emulsions. So the examples of emulsions included the surfactants. Examples are twin and spans. And also the hydrophilic colloids. Examples are acacia, and finely divided solids. Examples are bentonite and vigum. They are emulsions. And it should be able to reduce the surface tension to below the 10 dyne per centimeter. And if globules are spheres, then the formula is F is equal to 6 YV upon D, where Y is the interfacial tension, the unit is in interfacial tension is the dyne per centimeter, and V is the volume of dispersed phase in ml, that means milliliter, and D, capital D, is the mean diameter of the globules. And delta F, this delta F is the increase in surface free energy. The increase in surface free energy, in the unit is ergs. So the increase in surface energy is calculated and unit is erg. And also the zeta potential can be measured by zeta meters and helps in the prediction of flocculation behavior of the system. And the dispersed phase system having the zeta potential value higher than 0.25 ml are considered to be stable. So which compounds are stable? Those compounds which dispersed phase system having the zeta potential value is higher than 0.25 ml, they are considered to be stable. That means they are more stable. And also the emulsions having internal phase less than 5% behaves like a Newtonian fluid. So those emulsions which having the internal phase is less than 5%, they behave like a Newtonian fluid. Then next, the combination of emulsions is preferred over the single emulsions. And also the hydrophilic twins and lipophilic spans are widely used to formulate the satisfactory emulsions. So next we see the surfactants. The surfactants are type in the anionic surfactant, cationic surfactant, ampholytic surfactants, and non-ionic surfactants. So let's see the first anionic surfactants. These anionic surfactants are monovalent and also polyvalent and inorganic soaps, sulfates and sulfonates. And alkali soaps include the sodium, potassium and ammonium salts, are lauric, myristic and palmitic, stearic and oleic acid are water soluble forms of oil in water emulsions. And also metallic soaps like calcium or magnesium salts are fatty acids, are water insoluble, and these tend to form the water in oil emulsion, that means W by O emulsion. And the organic soaps forms the oil in water emulsions, and the sulfated alcohols such as sodium lauryl sulfate forms the O by W emulsion. So this sodium lauryl sulfate we see in the preparation of shampoo. So the shampoo is also the form of emulsion, and in that the compounds like ZBTO and lauryl sulfate are used. So that means sodium lauryl sulfates, and this sodium and also the sodium diacetyl sulfosuccinate is frequently used as the sulfonates di 2-ethyl hexyl sodium sulfosuccinate called as aerosol OT. And the second surfactant is cationic surfactants, and they are cationic emulsions they are commonly used in the lotions and creams due to their remarkable bactericidal property, that means bactericidal effect. And the examples of cationic emulsions. So these cationic emulsions are domiphene bromide. So these domiphene bromide is cationic emulsions. And also other examples are cetyl pyridium bromide and others benzalkonium chloride. So this benzalkonium chloride we see in the ophthalmic preparation, that means this used in the eye preparation. And also the cetyl trimethyl ammonium bromide. So the next we see the non-ionic emulsions, and examples of non-ionic emulsions are, for example, are glyceryl esters of fatty acid and esters of sorbitol and their polyoxyethylene derivatives, and also polyoxyethene glycols, that means polyoxyethene glycols esters and their structures, and also the sorbitan fatty acid esters, and examples are sorbitan monopalmitate, these also known as PAN 40, and they are non-ionic and oil soluble, promoting the water in oil emulsions. And also polyoxyethylene sorbitan monopalmitate is known as twin 40, they are hydrophilic water soluble derivatives, they promotes the oil in water emulsions. Then next emulsions are surfactants are amphiteric surfactants, and examples are N-dodecyl, NN dimethyl betaine and lecithin, and also polyethylene glucose, that means PEG, polyethylene glycose, and these PEG esters such as polyoxyethylene glycol, this PEG is polyoxyethylene glycols. These polyoxyethylene glycols are 400 monostearates, are widely used to prepare the emulsified lotions and creams. So in the GPAT there is a question, which agent is most widely used to prepare the emulsified lotions and creams? They are polyethylene glycol 400 monostearate, and they are polyethylene glycols esters forms. So the next we see the natural emulsions. The natural emulsions are acacia. These acacia is the natural emulsions and is used most commonly. This acacia is most commonly used in the natural emulsions. And also gelatin. Gelatin is amphiteric, and the lecithin is phospholipid, is also natural emulgent. And also the last is cholesterol. The cholesterol is the most important natural emulgents. So the examples of natural emulgents are acacia, gelatin, lecithin and cholesterol. And these acacia and gelatin, it forms the interfacial monolayer, and the lecithin and cholesterol, this lecithin and cholesterol are form the interfacial monomolecular layer, and this lecithin is a phospholipid and forms the oil in water emulsion, that means O/W emulsion, and the storage of lecithin is in the dark place, and the cholesterol form is the water in oil emulsion. So this cholesterol is in the form of W/O emulsion. So next we see the finely dispersed solids. So these finely dispersed solids are the colloidal clays such as bentonite, Vigum oxide and silica gel, aluminum hydroxide, magnesium oxide, magnesium hydroxide are the most commonly used finely dispersed solids which acts by the forming of particulate film around the dispersed globules. So the finely dispersed solids forms the particulate film around the dispersed globules, and they are bentonite, Vigum oxide, silica gel, aluminum hydroxide, magnesium oxide and magnesium hydroxides. And the bentonite may produce both O/W and W/O type of emulsion, and they are depending on the order of mixing. So which is mixed first, either oil or either water in bentonite. So and the Vigum is also as an emulgent for the oil in water, that means O/W emulsion, but it is cheaply used as an stabilizer in cosmetic. This Vigum is cheaply used as an stabilizer in cosmetic creams and lotions. So you know that the cosmetics are the skin products. So these cosmetics are used only girls. So and also man, some cosmetics are most widely used, and the Vigum is the substance is used as a stabilizer in cosmetic creams and the lotions. So in the GPAT there is a question, which cosmetic agent is used cheaply as a stabilizer, and the right answer is Vigum. So the next is auxiliary emulsions. These auxiliary emulsions are incapable of forming the stable emulsions, and these auxiliary emulsions have the thickening property. Thus, the consistency of an O by W, that means oil in water emulsions, prepared by using the acacia, and they can be increased by the use of tragacanth or also the agar, that means agar-agar solution. We use this agar-agar solution in the microbiology, and these tragacanth or agar which act as auxiliary emulsions. So next we see the method for the preparation of emulsions. So there are two methods of preparation of emulsions. They are, first is dry gum method or continental method. So the ratio for fixed oil, the ratio of oil as to gum as to water for fixed oil is, the oil is 4, gum is 1 and water is 2. The ratio is 4 as to 1 as to 2. And for volatile oils, oil is 2, gum is 1 and water is 2. And for volatile oil, the ratio is 2 as to 1 as to 2. And oleoresins, the oil is 1, gum is 1 and water is 2. The oleoresins ratio is 1 as to 1 as to 2. This ratio is oil as to gum as to water. And next method is wet gum method, or this wet gum method is also known as English method. This English method or wet gum method, here is the acacia is triturated with twice weight of water and then oil is added slowly. So in the wet gum method, the acacia is triturated twice the weight of water and then slowly oil is added slowly. Then the third method is bottle or Forbes bottle method. So this Forbes bottle method, in that the acacia placed in a bottle and 2 parts of oils are added and mixture is shaken well, and an equal volume of water is added and the mixture is being thoroughly shaken. Then next we see the list of antioxidants. The list of antioxidants. The antioxidants are in the percent of 0.001 to 0.1% is added as an antioxidant agents. The antioxidant agents are gallic acid, ascorbic acid, L-tocopherol, butylated hydroxyl anisole, that means BHA, and propyl gallate, sulfides, butylated hydroxytoluene, BHT, and ascorbyl palmitate. These are the antioxidants. They are gallic acid, ascorbic acid, L-tocopherol, butylated hydroxyanisole, butylated hydroxytoluene, ascorbyl palmitate, propyl gallate, and sulfides. So next we see the preservatives used as emulsions. So in that we first see the types of emulsion and examples of this and characteristics. So the first type is acid and acid derivatives, and the examples of these acid and acid derivatives are benzoic acid, sorbic acid, propionic acid, and dihydroacetic acid. These are the preservatives used in the emulsions, and the characteristics of these acid and acid derivatives is the antifungal. So these benzoic acid, sorbic acid, propionic acid, and dihydroacetic acid are used as emulsion in antifungal. So the next one is alcohols. Examples are chlorobutanol and phenoxy-2-ethanol, and the characteristics of this alcohol is in the use of eye preparation and in synergism. And also the aldehydes. The aldehydes like formaldehyde and glutaraldehyde. So this formaldehyde and glutaraldehyde are used in the preparation, used in the emulsions, and the characteristics of this aldehyde is in the broad spectrum. And next is formaldehyde derivatives. The formaldehyde derivatives are hexamethylene, tetramine, mono, and dimethyl, methyl, all dimethyl hadantoin. So these formaldehyde derivatives are, the characteristics is broad spectrum, and the next one is phenolic, and the examples of this phenolic type is phenol, cresol, chlorothymol, and p-phenylphenol, p-chlorometaxylenol, that means p-chlorometaxylenol, and methyl p hydroxybenzoate, propyl p hydroxybenzoate, benzyl p hydroxybenzoate, and butyl LP hydroxybenzoate and butyl P hydroxybenzoate. So all are hydroxybenzoate derivatives in phenolic and phenol, cresol, chlorothymol, and p-phenylphenol and p-chlorometaxylenol are used in the emulsions. They are in characteristic is broad spectrum. So the last one is Quaternaries type. The Quaternaries type examples are chlorhexidine, benzethonium chloride, benzalkonium chloride, cetyl pyridinium chloride, and cetyl methyl ammonium bromide. These quaternaries, the characteristics of quaternaries is broad spectrum, and these all chlorhexidine, benzalkonium chloride, benzethonium chloride, cetyl pyridinium chloride, the cetyl pyridinium chloride, and cetyl methyl ammonium bromide, the cetyl methyl ammonium bromide. All these are the examples of use in the preservative used in the emulsions. And the last is mercurials. These mercurials are the type of mercuries. So the examples of these mercurials are phenyl mercuric acetate, sodium ethyl mercuric thiosalicylate. So these phenyl mercuric acetate, sodium ethyl mercuric thiosalates are the examples as preservatives used in emulsions as mercurials. And the characteristic of mercurials is the broad spectrum. So here is the end of this chapter, emulsion. So in the emulsion we see the some basic points and important points in emulsion. In that we see the droplet syringing in diameter 0.1 to 100 micrometer. Then these emulsions are thermodynamically unstable preparations, and they stabilize by the presence of emulsifying agents. They are emulsions or emulsifiers. Then next we see the test for emulsions, that such as dilution test, conductivity test, dye test, fluorescence test, filter paper test, cobalt chloride test, and emulsions. So next we see the surfactants such as anionic, non-ionic, cationic, and amphiteric surfactants and their examples. So next we see the method of preparation of emulsions such as dry gum method, or this dry gum method is also known as continental method, and also second one is wet gum method is known as English method, and last one is bottle or Forbes bottle method. Then next we see the list of antioxidants. They are gallic acid, ascorbic acid, L-tocopherol, butylated hydroxy anisole, butylated hydroxy toluene, ascorbyl palmitate, sulfites, and propyl galates. Then at last we see the preservatives used in the emulsions. So hope you understand all these emulsion topic. So hope you like this video. Please, if you like this video, please share this video to more and more to your GPAT aspirants as well as CT aspirants, and please comment on comment section. And this emulsion is the most important topic for your GPAT and CET exam preparation. So, and also like, share, and subscribe to our channel Pharma Extech. And thanks for watching this video, and stay connected with Pharma Extech. Thank you for watching. Stay tuned and stay connected with Pharma Extech. Thank you. Welcome students to our new YouTube channel Pharma Extech, the division of excellence. So in the last video lecture we see the suspension. So in the next we see the emulsion. So let's start to this chapter, emulsions. So